के ऊपर।
लास्ट टाइम उसको प्रॉब्लम हुई थी।
ठीक है जनाब, आपको मिल गया। इंशाल्लाह फिर बात होती है आप लोगों से। अल्लाह हाफिज।
जावेद, go ahead and you can start.
अस्सलाम वालेकुम।
वालेकुम सलाम।
सरोज भाई, क्या क्लास हो रही है या वो मीटिंग हो रही है?
नहीं, रेगुलर।
म- मैं समझा वो कोई मेंटोर मीटिंग है, ये क्लास नहीं है।
अरे नहीं यार, मैं तो आप लोगों की वजह से यहाँ पे आया हुआ हूँ।
नहीं नहीं, सोहेल तो बस सिर्फ लॉग इन करा के ना चले जाते हैं, तो यू गो अहेड एंड स्टार्ट। और
मैं फिर
चेक करके
उसके
देख
लिए
लो कि तुम्हारा वो जो शेयर करना चाहते हो वो सब काम कर रहा है कि नहीं। वो
नहीं।
सब
चेक
कर
कर
रहे
लो।
मैं रेडी नहीं हूँ उसके लिए। मैं अभी ड्राइव कर रहा था, मैंने कहा शायद मेंटोर मीटिंग है। मैं ये समझ रहा था कि क्लास नेक्स्ट वीक है।
हाँ।
तो अब क्या करना है?
तो आप अपना अपना स्टार्ट कर दें, इलेक्ट्रॉनिक्स का जो थियोरी है।
ठीक है, ठीक है, ठीक है। ठीक है, मैं स्टार्ट कर देता हूँ। 1 सेकेंड, मैं शेयर करता हूँ स्क्रीन विद यू। ठीक है, एवरीबडी कैन सी द स्क्रीन।
Yes, sir.
Okay. So we will start with okay. So let's review the one which is we already talked about in the past. So everybody has, because this link is very very important from your point of view, that can take a look. The packages sizes, all these common packages sizes are available. System, and this is
Sir, you are not audible.
Yes. So everybody is there, right?
Yes, sir.
Yes, sir.
Okay. Okay. Uh, okay. So these are species which okay. So these are the one which is called the tantalum packages.
सर आपकी
Tantalum
आवाज में डिस्टॉर्शन आ रही है.
packages are the one which is like a battery. You see that battery, right? Kind of a battery, A size, triple A, double A's, all these are the one which is packages are available on those one in tantalum capacitors. When we go in a lot of more details, we will talk about that one. These are the different sizes. As you can see that the dimensions, width, and the height. These are the three counts. These are tantalum capacitors are the one which is still square size, right? Just like I did mention about this one. These are the one which is passive components. You see that these are the passive components, and these are the one which is tantalum capacitors. Tantalum capacitor are normally a yellow kind of a color, and different package size are available, about the same size. Just like you can see that this is tantalum capacitor is normally in a yellow. I do not see here, but these are the one which is this is looks like in a black, right? So normally tantalum capacitor has a polarity. Polarity is the one which is defined as, you can run the current only one direction. If this is the call, if you see that, these are the one which is, this is very important part, you guys have to pay attention on it. This is the polarity. So you can run the current only one side. If you run the current other side, it burns the board. It burns the component minimum, not the board. It will burns the component if you run the electricity on other side. So you can run versus the other component there is a no polarity is there. You can always run the electricity on both sides. So this is, if you see on the corner of that one, this is the one which is we call polarity. So you can run only one direction. So these are the tantalum capacitor. I do not see that. Maybe this is sometime it is come in inductor normally come in a black size and um, and uh, and it has a capacitor versus diodes do not have polarity on it. So these are the tantalum capacitor. Tantalum capacitor has a a polarity on one side. Aluminum capacitors, right? Aluminum capacitor. Let me show you if I see any tantalum capacitor. If I know how it looks like. Uh, I think maybe this is the one. I want to show you some nice picture of it, right? Yeah, this is the size of the capacitor, tantalum capacitor. I don't see any picture. Don't go that much in detail, right? You don't require to have that much detail in order to do that. Anyways, it is about rectangular size. And if I come across when we will be reviewing the board, we will talk about that one. So aluminum capacitor is electrolytic capacitor. Um, let me see. I do not see. Panasonic is the one which is leading capacitors in the industry. It is this is the very current information. They are the one which is least expensive capacitor. I will go a lot of more details, but these are the one which is leading. Uh, they are okay, no problem. When I'll show you the board, I will show you more details about that one. But they are also one of the leading. Oh yeah, see, these are the one which is called electrolytic capacitors. These are the one which these are available in different sizes in diameter and diameter. Available like 4.2, 8 millimeter, 10 millimeter, 6 millimeter. These are the one which is showing you right. These are roughly about like $3 to $4. These are you see that batteries in Pakistan, D size battery जो सबसे बड़ी batteries होती हैं ना, you remember those batteries? These are sizes about that one. So main stuff is there for that one for uh, 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 for the capacity. Ultimately, price is some these like quite the energy on it. It provides energy very quick. You can always go and look at in the Wikipedia. Go there and look at this definition. I'm giving you some generic definition of those ones. Okay, so you see that one. Any other questions? Okay, let's move on to the next one. These are the one. These are the diodes. Remember that I just talked about that one diode. And there is no not here. Just these are the one well in only in 10 different diodes are available. These are very common type of diodes or sizes are available. As you can see that these are the diode sizes, the length and the width and the height. Normally, height is not very important, because when you looking from cost point of view, you can always find like, you always look for the length and the width. The next one is MELF. Which is used to be we used to these are also in the system. They are also called because these are the one which is normally are transparent. Give an example, how the map diode looks. 1 second. Right? Hello? Everybody can hear me?
Yes.
Oh, okay. Okay, good. You can see that these are the which is malware. These are the one which is there. Remember, these are transparent, right? These are the one which is just like a transparent. You can see that transparent. Some of them like this, but mostly they are popular. We used to call this one, the glass diodes. The reason for the glass diode because it used to be transparent. Now they are available also in a solid package too. You can see that these are the one which is transparent. These are the one which is MELF diodes. कहाँ गया भाई? Okay, yeah, we are back. So everything when you go there and you just type it in, go to Wikipedia and you can find a lot of more information there, right? But you don't, as a cost estimator, you don't need to know their definitions. And then another package is called, the next one is SOTs, small outline transistors. These are the one which is very common. These SOTs are normally, let me show you if there is any example. Let me, SOTs looks like, electron. You can find that one. So this is the one which is very common. All these are called small or outline transistors. So these are the one with normally packages, right? So these are the one SOT 23, SOT 323, SOT 416. All these are packages are available on SOTs. And you don't have to remember all these dimensions. Dimensions is always available to you, the dimensions on this one. On the website, you see that all these dimensions, that how big it should be, how big is that. All these dimension SOT 353, SOT 553, SOT 23, SOT 223, and all these are the common packages. So about like 15, 20 very common packages in SOTs. And but there are about more than 70, 80 packages for the SOTs, but the most common packages around like 15 to 20 packages. You see that these are also SOTs are, some SOTs are available in not like 3 or 6. Most common package in the SOTs are this one. Most common are packages in this one, but you can always find these SOTs in these packages, like where you have see 3 leads on this side and 3 leads on other side. And sometimes you can see the 4 leads here, like the 4 leads here. These are the count. So the way it has been defined in SOTs, right? You see that SOT 23 is the common name. And a SOT 23 could be SOT 3, SOT 5, SOT 23 is mean 3 means SOT 23-3 means 3 legs. SOT 23-5 means 5 legs. SOT 23-6 means 6 legs. SOT 23-8 means like 8 legs. And these are the 2 most common packages. 3 SOT 23, SOT 89. And the bigger package which is available, SOT 223. I'm not sure it's here or not, but if you type in the Google SOT 223, yeah. This is the one which is more common package. SOT 23, SOT 89. SOT 23 is the smallest one. SOT 89 is the one which is the medium one. SOT 223, roughly about $10 to $15. This one. SOT 23 depends upon, if it's a high voltage, it's very expensive, but normally it's about like 3 cents. SOT 89, roughly about 4 to 5 cents. SOT 23, these are the most common packages. You see that The size is much bigger on this one. You can see that the sizes is much bigger. How I can get the size B? B means B B B. It is no, sorry, D. C one is more millimeter. The size. This is the size. It's on the you 223, and you look at this. SOT 23 is A, right? AC. This one is like 4.6. It's much smaller, like almost half. And SOT 89 and SOT 23 even smaller than this. See, what is this? A, even 2.9. That is pretty much half of this one. Okay. So these are the most common packages, but among these packages, there are sub packages. As I said, the SOT 23, 3, 5, 8, 6. All these are available packages, right? So you can see all these packages. So, after whenever I say something, go back and look at this, what I teach you, and look at this one, because in this way you remember. When I keep telling you, you may not remember this thing, but if you go back and look at by yourself, then it's remembered in your memory. Okay, so the next one is I mentioned pretty much every packages, every kind of. This is we consider is a newer. When we use the word newer, it means like they came in the market 20, 25 years ago, because this electronic industries started about like 70 years ago for the common public. I mean, they started a little bit earlier than that. But when we use the word 2025, these are the DFN. You see that DFN, I already mentioned about that one, this package. These are the one which is, you see all these leads, right? These are the DFN packages. So you can see that 1, 2, 3, 4, 5, 6, 7, 8. 8, 16, this will be called LQFP 32. 3, 4, 5, 6, 7. Sorry. 7, 28, right? 7 multiplied by 28. So this will be called DFN 28. Because this has 4, 5, 6, 7. These are the 28 DFN. This is like advanced level of that one. Any other question? So pretty much we cover through hole, we cover surface mount, we cover BGA. You remember that about 2 sessions before that we cover the BGA. You want me to capture again BGA? Because this is the very, very important stuff, right? So, see, these are, on the bottom side of this one on the bottom side of that one, right? You see that the reason they call the ball grid array, these are the one which is common side. You can see that, right? The balls on the bottom, those rounded color bottom, these are the one which is coming in the package. When the temperature goes higher, go through the profile, Then it is called collapse, and then it is come on that one ball grid area. These are the 192 packages, 76 packages, 24 packages, not 24, 124 different sizes of ball grids. So the most common are three categories, two categories. One is through hole, which is going through the board, and one surface mount, which is we are placing on top. Among those ones are the one which is, the rectangular size. These are mostly the passive components. Mostly, I mean, not all of them are the rectangular components, and then SOICs and the ball grid array and SQFP. These are the more 4 or 5 major categories. The two major categories, through hole and the surface mount. And the remaining of those ones are the one which is available. So how these components place in the SMT machines, right? Let me show you. You can see my screen, right? You can see my screen.
Yes, sir.
Uh, yes. Sorry. One second. I want to show you something which is very clear for you and should be in a. The problem is that they are not showing in a. No, you want to see that. Hmm. See, all these are the component, SMD component. Actually, I want to show you some later on any other better video. They are just, I think, they are just placing these components, but these are the component, normally they are just placing. Let me show you. This video might be better. The main they put plain board, and after that they are placing. They put the solder paste on it, and after placing the solder paste, these are the one which is they are placing these components on the top of this PCB. So after that is going through the oven, and that the solder paste they place it, they become solid. And now this operator is just see, these are the one with PCBs. Maybe he can show you a little better. Ads. How we can skip this ad? I hope this will be a good video.
Okay, production area is for change of events, we ended up establishing our own facility. So we did it because problems supply issues and but this was an empty warehouse. We started with operating floor. It's final flat. Over the final, we have an anti-static wide areas, a anti-static environment. We are wearing anti-static straps.
These straps are to avoid the electrostatic discharge because you can destroy the components.
It's flexible equipment, it's quiet, and so it's things a current machine found in the floor, it's like a mini earthquake. The other beauty about it is it's very popular system, so that it's great capacity, it's with the line, so another little machine that it's got great capacity because it had enough capacity with the fire end of the line, if they are ovens that do the soldering. So essentially, this one little line here is about 600 girls inserting components overseas who was taking down the benches and inserting components onto a board and pushing down the
PCB comes. He will show in a minute plain PCB. This is a very good video to look at all SMT process. It is available all this website and everything. The recording is happening. Silk screening, right? Solder paste. There is a stencil on the top which is about 6 mil thick. See, this PCB is going. This is a plain board, no components on it, but there is gonna go on the PCB.
So automating the first thing. Now this is what we call a chip shooter.
Chip shooter. Chip shooter means a smaller component. You remember I told you passive components? They are the one which is placing the component. 15,000 components. Place it, each component has those, 5,000 component. Remember I told you capacitor 0603, there are many 0603 different kind of capacitors. So each reel has, see, each reel has about like 5,000 component capacitor 0603s, 0402s, 0805s.
Process stops. Red light comes on, operating comes on, and sorts of things, but it will not slow down. That's the meaning.
So it is called a feeder. Feeder contains many of those reels, which is called the, they are placing, maybe about 20 reels. Suppose in the board, there is about 100 different kind of boards. So one feeder contains maybe about, see, these are the one which is called screen, right? So let's see that only these component you can place it on this.
Yes, you do. Many hundreds. Okay, the main advantages that the types of equipment that we've got, and it's another good thing. We have it varies depending on product, but half hours. It used to take a country like this. We run two shifts, we have run three, we do run three, we think. In place, this one is not a twin bed, it's not a shield, it's only a single bed.
So you can see there is on SMT machines, they are the SMT machine. You see that Yamaha, this is SMT machines, and there is a feeder on the side. You can see that, and reel you see all, and the board is going in there, and then you see that these machine on the top, they are placing from this feeder, this SMT machine is placing these component on the board.
That's exactly right. The third machine is actually quite a slow machine, but it is it's our place machine. It can replace things like microprocessors or whatever. It's capable of orientating the turning the logic, whatever. It picks up things like capacitive sensors that have fairly relatively high mass. Those machines have fairly high. It's also capable of taking microprocessors out of a.
You remember I talked to you about the microprocessor? This machine is placing the bigger component, like ICs, the microprocessors. You remember SOICs? This machine is placing this one. But nowadays, maybe this is a little bit old video. Nowadays, one machine can place all those passive and active component like SOICs, microcontrollers.
But if you run out of components sometimes, that's all you can get. Machines.
See, these are the place where they store all these components, right? Not reels. If they have to repair this component, the reels are there. This is a storage, right? You see that the part number is there and all that stuff. So they take this machine, take this reel and put it into the on a feeder.
We will supply probably on average 80 components. The only thing that we ask them to buy in is any components that are specific only to their own. So they buy them basically and we store them. There is slight variation. We can run these two lines. Everything is done. You can run these two lines. Probably an average about 3 people will move around in 2 lines.
So these machines are fully automated, right? Only time you need operator when they have to replace the reel. If suppose those 5 components are done, see, one operator is handling maybe many of those machines.
Our engineers yeah, we're well don't worry about so the boards go through the oven. They're essentially soldered.
So there's the oven where we have placed these with the stencil, the solder paste. After that, the component has been placed, right?
So the sticky back there. So they just really place that in there through the process. They go through the oven. And the oven then solder people is pretty preloaded, preloaded, and then they go through the process and they go into the trays.
So these are the one which is oven, going through the oven, and these joint become solid.
So yes, so we know that, and it's an interesting sort of thing in that they are in trade
And now these are the trays. They put these component here. There is inspection. She's doing inspection, right? After that, all the component is sometime there is inspection machine. It's called AOI, automated optical inspection machine. And if they reject it, then go to this operator. He's gonna repair that component. He's talking about this nitrogen. Nitrogen is help you. Nitrogen is very expensive. Most of the SMT houses don't use the nitrogen because it's very expensive. But it makes the solder joint more better.
but as a rule, we don't. There's very little of our production needs to actually go outside. Substances that are only about 5% factory that would normally have. In fact, this line is actually capable of quite small. We don't quite push it that far. Nearly close. It's and partly because, mostly because it's nitrogen based. We have the instruments outside. It floods the chamber with nitrogen. Gives us the wave sort of big horizon.
Oh yeah. I want to show you this machine. This is the machine they are using for. See, this is, you remember I talked to you about the through-hole component.
We have.
See, there is a bathtub on the bottom where all the melted solder is.
The interesting thing is that we have multiple ways.
And that you can see, I mean, it's a little bit difficult to see, but you see that the board is going above this bath. And for the capillary actions, the solder is going between those holes where we place the components.
Especially from boards that have sorry, from components that are say have a through hole with leads that are either poked through a long way or they might be a can, with these little tabs that poke through. And it gives us much better yield. It prevents things like short circuit. No, that's right. Yeah, that's the interesting thing. And precisely the way we had to go through the way solder process. So far, it's fairly, I would say, fairly typical, except for this particular machine. Very few people have a wave solder machine that could exist, but we really don't need it that often because most of our soldering is done on the enterprise. But this is probably boiling probe was in its absolute infancy when we talked about it. We set up earlier, it would have been late 90s, probably 97, somewhere around there, 98. be mistaken, but I won't be too far. Now, every board.
See, when they are placing every component, it is showing in the picture the placement. The placement has to be so accurate that 0.001 millimeter back and forth. See,
When we design a board in R&D, we spend almost too much time sort of building and designing. We saw this machine many years ago at a show, and it was being used to pick up boards. It operated standing, open space the board. The board would bring the marks and sounded like it had some merit.
so after that, it is called ICT and a functional board. ICT is the one where they check the test capital equipment, roughly about $500,000 ICT machines, and they check the electricity are going correctly or not. Versus functional test, end of line tester, we also call end of line tester. They check the functionality of the board.
We're gracious enough to allow us, and also to compare with another machine. And some machine looks way more impressive, looks way the magnetically operated machine. It sort of stood about the side of this. I mean, your heart says that's your heart says. The files go up with yourself. Well, how do you know? Do our first stop. We loaded a new set of boards into the machine. We've run it through the whole process. We get to this point, and only at this point when we say, good board, all the right components, because this is fine if it was otherwise. Then we press the go button. We don't feel the board goes that way.
So the board is passed.
Okay, now you're measuring the fiducial mark. Error correctly.
Fiducial or the mark which are on the corner of the boards. So every component is measured from this fiducial mark.
22 out of tolerance or whatever.
So the fiducials are the mark on the corner of the boards, and that is the one from every component counts, that how far is that component, which angle is that component, and how the placement will be due.
So we know without doubt, what sort of yield we're getting. And we monitor those yields, and that's a process in these types of reports. Now, that's two such things as struggling. So we may have a chip that without an iron chip that we may have several different brands. It's monitor the sort of magnification you can get. And you can train the machine to look for things. It could be anything between, the alignment of a header or whatever, to such things as targeted such. We may have a chip that a garden variety chip that we may have several different brands. It might be several sort of, single chip, a gate or whatever. And we have Motorola and National or whatever. Exactly. But in this specific board, we know that it really has to be Motorola for whatever reason. The engineers have specified that. So we can check that, if someone hasn't done the wrong thing and placed the right part with the wrong brand, we avoid making that. There are many other. The top-down camera here is looking at the component marking here.
So these are the marking. I'll show you. These are the marking which is identify those components. You see that seems to be this is a microcontroller, in my opinion. I think it's a microcontroller. By looking this marking, you identify who's the manufacturer, and with the marking, we can identify what is the part number of this component. they do not put the full part number on the marking.
We can do that. And also too, we've got angular cameras coming from the side, so we can come in from this side. Yep, coming from that side. We can also come in from this side and come in from the back side. And once again, we go back to the normal thing. So we can use any of those cameras used to inspect what we want to inspect. It generally does all the down views and comes with scan the barcode and whatever machine is found to be an issue will appear up here on this screen here. She'll work her way through that. What the machine, not necessarily the machine may find is an error, may not necessarily. The machine has what's called false balls. Very early stages. We don't do that.
So after that, these boards are not going through a single one. Sometimes 3 boards are combined. They run on a SMT machine, or 4 boards they combine, and they separated those after this. So that's the one they are talking about. They are also called monkey bite. On the corner where you can separate it, or the V group. See, they are cutting the boards. If there are 4 boards, it's called array. And from array, there is another one is called panel, like which is 25 by 20. See, these are the sides. They are removing these sides. They are removing these sides because these, when you're running on a conveyor, you need a side. So these are the ones they are cutting the side. See, they remove all these ones. The V groove is like a V groove, right? See, there are many boards in when we are doing this thing. Now they are singulating these boards. See, they were running. No more than 8. See, the board size is much smaller. So they are running maybe 16 or 32 boards. And now they remove on the side these rails where they're running on and then they singulated the boards.
And we even check the balance of the 2 halves of the unit. Yeah, they have to be waterproof. People wear them in the shower. So we actually.
And after that is going to the storage where they're going to storage. And they put it in a electrostatic discharge where they are safe. It's normally a pink color. kind of a transparent.
Okay, so here. Energy capture, yeah. Tremendous.
Okay. 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 So any question? The video which I uh, get a chance, take a look of those video in full 50 minutes, watch full time again, but I show to you, or you can also first listen this recording, right? The one which we have done today. Listen this recording first, and then you go back and look at this SMT video. They give a very good example, how to do the placement of those one. Some of the placement may not be accurate. I mean, normally in 1 second, on an average, they can place up to 10 passive components. So imagine how many seconds in 1 hour. Anybody can answer.
3,600.
3,600, right?
3,600.
Yeah, perfect. Okay. So 3,600, and you are placing 10 component. So you can plate up to 36,000 components. This is a very conservative number. Some SMT machines claim that they can place up to 7,000, but based on my experience, roughly you can place about 45,000 passive components. 1 second per component, 10 component per second. This is, I give just an example. Actually, you can place in more than 10 components in per second. And for the ICs and it depends upon what size of IC and everything. You can place into 0.1 second to can place up to maybe 0.6 second one component, or maybe 0.2 or 0.7. But definitely 1 second normally good enough for any ICs. Some ICs are taken a little bit longer, takes it maybe up to 2 seconds or 3 seconds, but normally does not take too long. So this is the session for today. And I don't know, do we have to do anything? It's fully recorded. Where I was. Where to say Stop recording. Okay. Now the recording has been stopped. And any question for today's session?
No, sir.
Not working for me either. Hey, are we done now? Hey, okay, good afternoon. Thank you.
If I think Gaur sir have left.
Okay, good afternoon.
Allah Hafiz.